Good morning, everybody. A very warm welcome from the CIGRE in Paris. Next to me, I have the director of our R&D, Mr. Jürgen Schwarz. Good morning, Jürgen.
Good morning, Johannes. Thanks for the welcome.
Well, we have a technical session today, and what we like to talk about is what are the trends in the transformer industry. So for the last 4 years, of course, a lot of things have changed, and we didn't have a big convention due to the COVID pandemic, but the trends, the technical trends, did develop further in this time. Jürgen, what do you think, what have been the technical trends in the last 4 years?
Yes, unfortunately 4 years we have not been here live. Now we're live here at least on the TV. The trends went on. We looked into the market, we looked around, and yes, we foreseen that there is a trend to bigger ratings in the transformer industry.
How is it when it comes to the demand from the market? I do remember that in early 2018, I was approached by a German transmission operator, and they were asking for a tap changer in vacuum technology for higher currents, means up to 3,000 something amps. This was the demand at that time. And well, we see the thing behind us, so it's existing already, but maybe you can give a bit further insights in this.
Yes, I would like to elaborate a little bit further. When we looked into the market before, we spoke from the trends. As a kind of market leader with a vacuum technology, we're in the market since more than 30 years with the vacuum technology. We have more than 85,000 tap changers in the field. We were always looking around, so we were not really surprised when the transmission system operator Amprion from Germany came to us and said, look, we have here a huge phase shifter which we would like to install. The ratings of the phase shifter have been 400 kV, 2000 MVA and 3000 amps. So it wasn't really a surprise from us because we already started with the development. So for us it was the perfect situation to be early in our production, in a development stage together with the utility. Definitely also with the transformer manufacturer, going through the designs, making sure that what we expected to come also fits 100% for the market. So we had a good team sessions with the OEM and the utility designed for that specific application. And it was already a success because the tap changer which we developed for the market, the OEM liked that much that he already used it for another phase shifter in Canada.
That sounds perfect to me, and I do remember that we installed, I think, the first one for Amprion in the, I would say, summertime of 2020, and it's now in operation for, let's say, almost 2 years. When we come to the technical data of the unit behind us, can you give a bit more details about the technical data?
Yeah, we just mentioned for the first phase shifter we had a 3000 amp, but yes, we considered the whole world market, so we not ended up with 3000 amps. Step a little bit to the side, you can see here in the back the technical data of the tap changer are that we have a switching capacity of 10,000 kVA, we have a step voltage of 6,000 volt, and yes, the maximum current is 3,200 amps, and this is unique in the field.
Thank you very much for the technical details. When, of course, you know, there were the requirements for the phase shifters, and we are now thinking about other applications. Can we talk a little bit about the advantages of this unit?
Yeah, I said before that the OEM was using that design which we developed together with them and a utility in Germany for another phase shifter, and the real outstanding benefit for the OEM is there is no need of enforced current splitting. This makes the design of the transformer cheaper, and you can build the transformer much more compact, and this is also a benefit for the utility.
When I think about the tap changer and I think about 3,200 amps, I think there are some challenges that go along with this kind of current and also with the application. Can you talk a little bit more about the challenges during the R&D process and where we are now with it?
Yeah, when you go through new shores, you always have to overcome some challenges. And we said already the 3,200 amps is unique. Going to that direction, we had to find out new things around the transformer, around the tap changer, and we had to make sure that we have a safe operation. So we invented some things which we patented. We call it the advanced arc control system. This makes sure that the arc extinguishes at the right time and the contact wear is not too backed in the vacuum bottle itself. Secondly, we have the step protection system. Yes, we have to protect the system. We're protecting also the transformer. If there is a lightning coming, we have an overload condition. We have a step protection system, which is good for the transformer as well as for the tap changer. And last but not least, we have the advanced flux control system. Again, the 3200 amp is a new field, a new area we're going to, and with the current there comes an acting magnetic field, and you have to have some considerations to make sure that you have a safe operation.
Yeah, I think when we talk about the step protection system, if you have a closer look to the tap changer itself, you will see that there are some non-linear resistors in here this is part of the step protection system. When you talked about this advanced flux control system, this sounded quite interesting, so maybe we can go a bit deeper into this.
Maybe sort of a glimpse into the technology. If you have 3,200 amps going through the tap changer, through the leads, that causes an acting magnetic field. The acting magnetic field, again, has interferences with the operation of the tap changer, mechanically as well as electrically. So if you think about the arcing in the vacuum bottles and the magnetic field, the arcing is actually deflected, not to a point in the bottle which it never used to be. So we had to take consideration of the magnetic field. You have to understand 300,000 switching operations during the lifetime of the transformer is something typical for a phase shifter, so the system must work for 300,000 switching operations. Abnormal contact wear, this had to be a consideration. That led to special design in how you would do the connection leads to the vacuum bottles, and we had to implement some magnetic shields.
Okay, well, thanks for that. I do remember, you know, when I look at the transformer, you can also see that sometimes the installation is on the front end of the transformer, where the magnetic flux from the windings might be different to an installation, you know, when you have the three single phases somewhere along the long side of the transformer. And I think this is what you take into consideration when you talk about this advanced flux control.
Yeah. So we're taking this into consideration whenever we do a tailor-made design with a transformer manufacturer, but not always you get all the information, not always you know exactly what the system will see in the field. So as I said, we had to take some considerations in the tap changer itself to make sure a safe operation.
Well, this is perfect, and I can add that we have a team of technical specialists. Each time we get an inquiry or get some request from you for a new application, they will look very much into the detail of the transformer and discuss with the transformer manufacturer what is needed to make the perfect design. When we talk about the design and the applications, we talked about phase shifters quite a lot right now, but I think there are other things that we can do too.
Yes, we said before we considered the whole world, the whole market, and it's not only phase shifters. There are other applications which are growing to new demands. So we have, for example, the HVDC application. There you have a specific characteristic, a specific need for the IDT characteristics, which this tap changer fits perfectly to. With the renewable energies, we have variable shunt reactors coming much more, also with a high demand of technical data. Perfect situation for that tap changer. We have the arc furnaces, electrical arc furnaces. There, the 300,000 switching operations is not really the lifetime of the transformer, but they're also going to bigger power ratings. So this is also what we saw and what we have the system built for. And last but not least, the grid transformers, not the normal one in the big transmission lines, going up from 300 to 500 MVA and above.
Jürgen, thank you very much. I do think maybe we talk a little bit about the portfolio. We talked very much about the upper end, the 3,200 amps. We have a standard VR three-phase unit up to 1,300 amps, and I think after the 1,300 amps, when we go to the higher range, then we start with this kind of tap changer.
Exactly. we had to extend our portfolio for the market demand. So 1300, this is what we had before. So we extended it, and we had now several applications and several demands. So it's not only one tap changer who fits for everything. We have a portfolio now starting from 1600 amp going to 3200. So 1600, 1800, 2000, 2400, 2600 amp, then 3000, and then the ultimate one, the top one, the 3200. So we have the portfolio designed in a way that we can fit into the right application, the right tap changer, almost tailor-made.
That sounds perfect to me. So I think we can cover the whole range of applications and the whole range of current ratings with that. Let's talk about the installed units we have. So far, we said that we started with the first applications with handmade tap changers that we installed in 2020 in Germany. From that time on, we have now the fully industrialized product that you see behind us. And what other references? What other reference can we give here?
Like you said, the industrial version we have by the end of 2021. So we just like 1.5, almost 2 years in the market. We're speaking about the big transformers with long lead time. So if I say we already almost sold 100 units, this is actually a big number for big transformers with these long lead times for that short time. So we have close to 100 units already sold to the market. It's very good. And we see in all the project discussion which we're having, we have hundreds of offers and project discussion with our OEMs and end customers. So we really see that we have a good product for the market. There is a market demand which we foreseen, and we're actually ready to deliver. It's good to have a live show, but also we not only want to say this is a demonstration unit, it's live, we're ready to deliver. Maybe we just make a switching operation so to see the system is actually working.
Yes, let's do that. Okay, I'll start the operation. Well, if you look here inside to the vacuum interrupters, I will do another operation. You will see the vacuum interrupters being operated.
As you can see, it works, and I give you my word, it's also working in the field. We're ready to deliver. We're here still in the middle of the CIGRE. I think it's Wednesday, the middle. There's another 2 days to come. We're here at the booth, sorry to look at it, S153. So we're looking forward to maybe see you also in live here at the booth, and would like to welcome you here if possible.
Jürgen, thank you very much for the very detailed explanation. We have come to the end of our show, and I do think the next streaming is at 2:15 in the afternoon with another technical talk. Thank you very much for watching. Bye.
Thank you very much from my side too. Bye.